right? Yeah. The importance of queuing theory, it deals about the customers and what is the service providing to the customers, and it deals about the queue, what is the queue, how we can define a queue, what is the definition we are giving for a customer. These things are the basics which we have to learn in this queuing theory. Okay, so here we have one small introduction about this queuing theory. This theory, it speaks about a flow of customers from finite or infinite population towards the service facility forms a queue. Okay, so here queue means, what is the meaning of a queue? Is a waiting line. Okay, queue means waiting line on account of lack of capability to serve them all at a time, right? So that is queuing theory, right? I think you understood about the introduction of this queuing theory. So here we have to concentrate on the customers, and we have to concentrate on the queue waiting line. Okay, so here we will see how it is learned in depth. So this queuing theory, we will start with this customers, knowing about the customers. See, what is the definition of a customer? Okay, customer. Customers, we can say the arriving unit. Customer means he is coming to us in need of any service, in need of any requirement, like that. The customer is coming to us. So here what we can say about this customer, the arriving unit that requires some service. He needs some service. The customer needs some service to be performed. To be performed is called customers. Okay, so here the customer may be person, he may be a machine or a vehicle, etc., like that. It may be in any form. And next form of this queuing theory is queue waiting line. It is queue waiting queue waiting line, right? Queue waiting line, here we are saying that it is the queue discipline. Here we can say under this queue discipline, the customer means it is a rule according to which the customers are selected for service when a queue has been formed. Okay, when a queue has been formed, the customer are selected for this service as per their requirement. So the most common disciplines here are the first come first service. Here we can see first come first service, and second is first in first out, first in first out. Third is uh, last in first out. Okay, third is last in first out. Okay, last in first out, like that. We are having these disciplines. We are, according to this, the customer has to be selected, right, based on his requirement. And one more we have, that is selection for service in random order. Okay, one more we have, selection of for service in random order. Okay, yeah. Now in order to continue, in order to learn this queuing theory, we will select one problem here, and we will see how this problem can be solved. Okay, I think you are understanding our class. Yes, so yeah, the problem is ready now, the question is ready. Okay, you can see this one. I will read it. First we will understand the problem, and later we move to the solution part. Okay, yeah, just concentrate here. I'm going to read this problem. A departmental store has single cashier during the rush hours. Customers arrive at a rate of 20 customers per hour. The average number of customers that can be processed by the cashier is 24 per hour. Assume that the conditions for use of the single channel queuing model apply. So here we are going to apply single channel queuing model, right? And we are going to find out what is the probability that the cashier is idle. Okay, and next, what is the average number of customers in the queuing system? Next, what is the average time a customer spends in the system? Next, what is the average number of customers in the queue? Okay, so I think this is the given question, given problem for us, which is falling under the queuing theory. Okay, right. See, the most important thing in order to solve these type of problems, these type of logical problems, we have to understand the question properly, right? So many of us don't read the problem, don't read the given question properly, right? And it takes a lot of time for solving in those conditions, right? So what experts says to us regarding these type of problems, we had to read the problem carefully. We had to understand what is the exact data given in the problem. So once we are familiar in this type of reading the problem properly and understanding what he's asking, so it helps us to give a good solution for that problem. Okay, right. Now for this required problem, we will see the solution here, right? So see, the solution first, right here, this is the solution, right? So here what we are saying is, first we'll take this lambda as mean number of arrivals per time period, right? This is number mean number of arrivals, right, per time period, per time period, right? And next, this is mu, this is mean number of units. Here comes mean number of units served. Here this is served per time period. This is served per time period. Okay, so these things we have to write in our solution. Now we'll move to the solution, right? So first thing is, we'll find out arrival time, right? Arrival time is, in our problem, what is the arrival time? Lambda is 20 customers. Okay, lambda is 20 customers uh, per hour. And service rate mu is 24 customers. So this is 24 customers per hour. Okay, and next, what will be the utilization factor, right? Utilization factor is rho, and this utilization factor rho, it is lambda by mu. Okay, lambda by mu, and we know this values as 20 by 24. This we can write by 5 by 6, and it is 0.833, right? And next, after finding the rho, we'll go for WQ, right? We'll go for WQ, right? So what is the WQ here? See, this is average number of customers in the queue, right? So WQ means average number of customers in the queue. So this WQ is row into WS, right? Row into WS. What is WS here? Average time a customer spends in the system, right? We know what is WQ here and we know what is WS. This is the row into WS, right? So row value, this is the row value we have here, 5 by 6, and WS is here. WS is how much? 30, right? WS is 30. So here we'll take it as 25 minutes, right? So WQ, what is WQ here? What is WQ here? Average number of customers in the queue, right? So here we are writing here as 25 minutes, right? Right. Next, we'll see this WS, right? WS is we know 1 by mu minus lambda. So we'll write here 6 by 5, right? And that is it is half an hour, and we can write again it as 30 minutes. Okay, half an hour, right? 0.5 hour or 30 minutes we can write here, right? So this is the part of the solution, and here we can see what is the exact thing he is asking here. So what is the probability, right? What is the probability that the cashier is idle, right? So based on this given data, what is the probability that the cashier is idle? So we'll see here solution for A. Okay, so row, this is row not, so 1 minus row equals 1 minus 0 0.833, so we'll get 0.167. so the probability that the cashier is idle is, this is the probability of the cashier is idle. Okay, and next is next one, what is the average number of customers in the queuing system? Yes, this is LS. Average number of customers in the queuing system is LS. So it becomes we lambda by mu minus lambda. So we'll get 5 customers. We'll get 5 customers, right? So what is the average number of customers in the queuing system is, we'll get 5 customers, right? So A, we came to know about A, we came to know about B, and we'll see what is the question, what is the solution for C. Okay, C means already WS we have seen here, right? Already we have seen WS, C is WS, and D is WQ. Okay, D is WQ. This WQ will write here. Okay, so we know this is row into WS. Okay, and this is 5 by 6 into 30. We'll get 25 minutes, right? So like that we have to solve this queuing theory. Okay, so this is for a given problem, these are the steps, right? And these are the formulas we are using. This is the formula, this is the formula, right? And this is the formula we are using for solving this problem. Okay, So hope that you understood this problem. If you are having